Hello, welcome back. Welcome back to another video where we experiment with the Homelab setup using Proxmox. So far we have built a virtual machine template using NixOS, which we can use to create further virtual machines. So I have already used this to create a couple of VMs, and it's already running a couple of my stuff. So we are going to be building a lot more virtual machines, and we are going to be creating and deleting them quite frequently in the future. So in order to make this much more easier, what I'm going to do in this video is to convert this Terraform code into a module. So we don't have to specify all those parameters, and this will simplify us for creating further virtual machines. And after that, we'll also work on setting up some storage buckets in MinIO. Sorry, it's not TrueNet, it's MinIO. And we will also use Terraform to create those storage buckets, and same way similarly we are also going to create a module to create the MinIO buckets, the users, policies, and all those stuff. Okay, so let's get started. So far we have this virtual machine for NixOS test and also one for Darkland. So this is the one which we created in the previous video. So I'm going to use this code and convert this into a module. So first of all, let's create a new folder in the root directory. Let's say Terraform modules. So inside that, so we need to define the inputs for this module and also the outputs from this. Then we can move this resource over there. Okay, so variables outputs.tf, and then we can move this into main.tf. Okay, so my bad, we should call this QEMU VM. Let's move everything inside. Okay, so this will be the module for creating a QEMU VM in Proxmox. You know what, let's make it Proxmox QEMU VM. Okay, I hope that is clear. Nope. Yep, QEMU. Okay, let's make all this generic. So what are the variables we need? So we need the target node. Okay, let's look at the documentation. Variables. So we need to provide the variable name, type, and the default. Okay, so type equals to string. This will be a required variable. Okay, and then agent equals to 1, so this will be var dot target node. Okay, agent will be 1, BIOS will be this one, and for this we can have another variable for the clone base. Okay, var dot clone. Okay, then we can make this also a parameter. Of course, this will be a number, and we can also provide default equals to, let's say, 2 cores. Okay, and description, of course. Type equals to string. So this will be the description for the virtual machine. So var dot description. false create is false, full clone is always true, and we can leave all this as it is. But here, yeah, we need to take the IP address as a parameter. Then, so this is going to be, let's say, variable IPv4. So let's add a description to make it a bit more clear. So let's add example to make it more clear. Let's 192.168.1.2/24. Okay, I hope this example is clear. Type default and description. Okay. So okay, then let's change that here. var.ipv4 gateway. Okay, and IP6, let's leave it as it is. So eventually we will see if we have to make it dynamic to be able to give static IP or not. But for now, I'm going to be using DHCP for all the VMs. And memory is going to be a variable as well. So cores memory will be a number. So let's leave the default as 2048. And then name, of course. Okay, on boot we can, I think let's leave it true by default, and SSH keys, of course. So this is going to be a string. Okay, okay, protection equals to false, so we can leave most of this as it is. VM state, we can give it as a parameter. We can also leave the default as running. Okay, and for the disk we would need the cloud init for sure, and for the virt.io we will give the size as a parameter. So this will be var.disk size. Okay, example 30G. So I'm gonna give a default here as well. So let's say 50G is the default. Okay, network and everything, I think everything is fine. All right, storage. Ideally, if you want to use it across like in a much bigger environment, you would need to configure a few more things. For example, the storage, you may have multiple places to store the disks. So in my case, it's pretty simple. So I think we have defined all the inputs, and in the outputs, what do we need? Do we have the VM ID here? Okay, where is the VM ID? Okay, so I would like to give VM ID also as a parameter, so let's give that. VM ID equals to dot VM ID. And this should be a number. Okay. And this can be nullable, I think. All right. So if you leave it as null, then never mind. Let's not leave it as null. Okay. So we have the variables, outputs, and so what do we output from this one? We can output the IP config, so it will be useful to see. And yeah, we can output the VM ID and honestly, I'm not sure what should I give it as output. So for now, let's give IP config as an output. Proxmox VM Chemo. Let's see what they allow us to provide. So attribute reference. Okay. SSH. Okay, so I think we can take this as an output. So we will get this once the VM is created and once Proxmox can read it. So IPv4. Proxmox VM Minio.this.default IPv4 address. Okay, so we have this module almost set up. We just need to add a couple of things. So next thing we need is a Terraform TF file to define the required providers. Modules example, let's see. Creating modules. So we need to have input variables, output variables. No. Yep, so we need to specify the required providers here. So let's do that. Okay. Required parameters and also the we also need to provide the Terraform version. Okay, module structure. Root module, readme, main df. So let's see. And what is our okay, so let's make this as a required version. All right, so I think the module is almost ready, so let's try to use this module and create a new VM. So okay, so let's call it Fireland. So this is going to be, so this VM is going to be used for setting up a game server for Valheim. Okay, so let's create a new VM called Fireland using this module. Fireland.tf. Okay. // Terraform modules Proxmox VM Camo. Okay, so let's init it first and see what happens. Okay, before that, let's do a Terraform format. Okay, go to Cosmos, Jupyter, and then Terraform init. Okay, so it's complaining about some numbers. Okay, so I think the type does not need a string, so type equals to number. Okay, perfect. So we have the module imported, and let's see what shows up in the plan. Perfect. So it is complaining about the required arguments. So let's provide it one by one. Okay. VM ID is going to be, let's say, let's say 201. Okay. Target node equals to Jupyter. Name equals to Fireland. Clone equals to NixOS base. So we are going to be cloning it from this one. Cores equals to 2. Memory equals to 4096. Okay. This is equal to Fireland Valheim server. Okay. SSH keys equals to, so I can copy the SSH keys from here. Okay. IPv4 address. One 168.1.70. Oh, forgot the /24. Gateway is 1.1. VM state is running. Disk size, we are gonna need a bit more than 50 GB. So let's say disk size equal to 100 G. Okay, let's do a format and a plan. Undeclared input variable VM ID. Okay, this should be VM ID. VM ID. What did we miss? So we are calling it as VM ID here. Okay, so let's change it to VM ID here, here, and also here it is correct. Okay, Terraform. So we need to init whenever we change something in the module. Okay, perfect. So Nixos base description, IP config is correct, SSH keys are added, and VM ID is there, cloud init is there, disk is added. Looks good. Let's try to apply this. So if you look at this module now, see how simple it is. So this is how modules are created. You simplify. So this allows you to simplify the parameters to create new resources. So instead of providing this big of a configuration, you can provide only the necessary details to create a new resource. Okay, so it looks like the VM was created. Let's see what happened. And as you can see, the VM has been created successfully. And let's see, it has already started. That was pretty quick. 2 CPUs, 4 GB of RAM, and in the hardware, it got 100 GB of disk. And in the summary, I can see the IP also. So let's see if I can log into this. So I already added my SSH keys, so I should be able to do root@1.70. Perfect. So it looks like it's working, and IP address is correct. What else I need to check? The disk, and as you can see, the disk is also correctly mapped to the root. Okay, looking good. So we could take this a step further and create a variable here which defines a list of VMs, and basically this whole thing will be a variable here itself, and we can provide them as an array of objects with all the required parameters, and here it can just loop through it and create them one by one. But let's leave it here for now. This is only much more simplified, and I'm going to delete this NixOS test VM because we don't need this anymore. So let's close this. Let's apply again. So we are going to destroy this. Okay. We forgot one small thing. So remember, we have the IPv4 address as an output. So let's use that here. Outputs.tf. So we can use this. So we are going to be using the output from Fireland. Okay, I think that should work. What happened? Module.fireland.default IPv4 address. Object does not have an attribute named default IPv4 address. Okay. What is it called? Oh, it's called IPv4 address. Okay. Okay, I think it worked. Terraform output. Interesting. It's not providing this as an output. Okay, I need to do a Terraform refresh. No output found. Let's look at the console. Module dot fileland. Okay, it's null for some weird reason. And why is that? I'm not sure actually. So let's get rid of this. It's not really that important since we are providing the IPv4 as an argument anyway. Okay. Terraform module for creating VMs. Perfect. Oh. Forgot to add this folder. Okay, now that's out of the way. Let's create another module for creating now that's out of the way. Let's create another module for creating S3 buckets in the MinIO server. So let me show you my MinIO server. So I have a MinIO server running in my NAS. So I have some buckets here. So what I need now is the ability to create new buckets and also create new users and access policies associated with the bucket and all those things through Terraform. So my objective here is, so we are creating a new game server, right? So and this game server also requires an S3 bucket for uploading backups. So I'm using Rustic and using S3 as a remote backup. So we'll get into that configuration later, but before we get into that, we need to create the bucket here and also set up the credentials. Okay, perfect. So let's see how we can do that. So we need the MinIO Proxmox module. Sorry, MinIO Terraform provider. Let's see. So this one looks okay, but I think there is another one. Okay, this looks much better. So with this, we can manage the S3 buckets for MinIO. Okay, so let's see how we can use the provider. So to use this provider, we need to use this like this. Okay, so let's call it MinIO S3 bucket. Okay, and then don't forget the input and outputs. So this should be variables.tf. Okay, so in order to use this provider, we need to specify what? So let's add the required providers here first. So we added the the provider to the root module, and we need to add a new provider block for MinIO. Okay, so we need the MinIO server and the username and password. So the MinIO server is going to be not this, but this. Okay, because this is the admin console, and for interacting with the APIs we need to use this URL. Authentication using environment variables, that's better. So endpoint is already set. We need to export the user and password. So remember, we are using the envrc to set the password from pass. So let's use the same thing. We need to find the MinIO credentials from new pass. Let's see what's okay. So in the Homelab, I already have created the Terraform key and secret. Okay, so this can be used to interact with the MinIO API server from Terraform. Perfect. So this is going to be Homelab Jupyter MinIO Terraform key. Okay, so these are the credentials to access MinIO server, and we also need to specify that we are using HTTPS, so MinIO SSL should be true. Okay, let's see if it works. We forgot to do dir and allow. It's not in the password store. Terraform, Homelab, Jupyter, MinIO, Terraform key is not in the password store. Okay, so this should be Homelab MinIO. Okay. All right. It's still not clear whether it is able to connect to MinIO or not, but let's try to create a bucket and see. So go to resources, S3 bucket. Let's copy this whole thing. MinIO S3 bucket. This. So this is going to come from variable. So var dot bucket name, and ACL is going to be. I don't know if I ever need this ACL because it's always going to be private. And then MinIO ID and URL. What is the ID? Bucket domain name. Okay, ID is the name of the bucket itself. So this will go to let's call it bucket ID, and so we need to create these two variables. Variable type equals to. So this is a mandatory variable, and for the actually let's call it just name. This will be default equals to private. Okay, let's add a description to make it clear. Private or public. Okay. So we need to create a S3 bucket here for file and backup. So the reason I am creating it as a module is that I will also add the ability to create users and policies which are attached to this bucket in the same module. So almost all the time whenever we are creating a new bucket, we need a user associated with that bucket. Okay. So let's see if that works. Actually, I'm going to name it as a file and test bucket because I'm not sure, maybe I might have to recreate it later. So let's see. Terraform plan. Okay, we need the module plan, and it doesn't work because the name has been changed. Okay. Clan creation failed. Endpoint URL could not have fully qualified paths. Let's see what we missed. Okay, so we don't need HTTPS here, I guess. Okay, that looks better. I think it's able to connect to MinIO now. So it's going to create a new bucket with the ACL private, and the bucket is going to be file and test. We don't care about the domain name and stuff, but we can provide this ARN as a output variable. That's going to be useful. So but for now we only need the bucket ID. Module dot S3 dot bucket ID. Okay. Okay, so this is going to be new output. Apply, and it failed. Specified bucket is not valid. Okay, so I believe that's because we need to make it as a hyphen. This should be a yeah, it doesn't support underscores. Try again. Perfect. Go to the console, update browser, and so here you can see that it has created this new bucket. Let's see. There is nothing inside. This policy is private, and okay, looking good. So next we need the ability to create a user and attach a policy for the user to access this bucket. So I'm going to make it under a variable. So let's see. Create user. This should be a pool. Default equals to true. We have to create a user to access this bucket. Okay. Let me refer my previous project quickly. Infra. Bucket user IAM policy attachment. Okay. So we need to create a new IAM user. I don't think we need to complicate this, but let's. Okay, so this is going to be user corresponds to this bucket. So let's give the name as var dot. Okay, let's use a bucket name hyphen user. Okay, we don't need all these things. So this creates the user. Now we need a IAM policy to access this. Okay. Oh, we forgot one more thing. So this should be dynamic, as in we need to create the user only if this is true. Okay, so that means we need to set the count based on that. Create user. Okay, so this will set the count to 1 if the create user is true. Okay. Now the policy. Same thing. Okay, the policy only if it is true. And name is going to be, let's call it default user. So that makes it a bit more clear. So we don't need to allow listing all the buckets. What we need to do, let's use this one. So this allows all the operations on this particular resource. So this .arm. Okay, so this policy allows all operations on this bucket and all the contents inside the bucket. Okay, and this will be created only if this variable is true. Perfect. And we also need to do user policy attachment. So this is what links the user to the policy. So don't forget this. Okay, MinIO user dot this 0. So since we are using count, it's going to, this is going to be an array of resources, even though it only has one element. So we need to reference it like this. Same way, this. Okay, so this is going to, okay, so this resource is going to attach this default policy to the default user. Okay, and Now that we have the user and the policy, we also need to output the create a service account and output the secret for this user, which we can use in our scripts to connect to this S3 bucket. Okay. MinIO IAM service account. So here the user. Okay. Let's see. So this creates a service account. Call it this, and target user is perfect. So default user key. Actually, let's make it access key and secret key. Okay, and the value is going to be IAM service account dot this. Again, this should be based on the create user flag. Okay, so access key is going to come from this user service account, and similarly the secret key will also come from this, and mark it as sensitive. Okay, so in the variables we also set this by default to true. That means if you do a plan again, it should create those users. All right, so as you can see, it's creating the new policy, service account, new user, and the policy attachment. So before we apply that, let's also test what happens if I set it to false. So this should not make any change now. Okay, so how do we make the output dynamic? So far we need to move the output from here to .tf. I'm wondering if we can make the outputs dynamic. Let's try to give the count there. Okay, let's see dynamic outputs. Actually, what we can do here is probably I think we can use an expression like this here. Let me try. So length of new IAM service account this 0 equals to 1. Okay, let's see if that works. Okay, let's do any need first. Plan. MinIO IAM service account. This is empty tuple. Oh yeah. Okay, so if the array has one element, use this secret from that. Otherwise, return empty. Awesome. Okay, it works exactly as we wanted. So, and if I change it to create user true. Okay, perfect. You know what? I think we should set the create user as fault by default. I think it makes sense like that way. Okay, and in the outputs we need to output the bucket ID and also the secret key and secret, because we need to use that to connect to the S3 bucket. Okay, so access key and secret key. Okay. Yep, we need to set this as sensitive equals to true. Okay, let's review this again. This one creates a AIM policy which allows access to this bucket, and this one creates a service account for the user. This creates the user. This one creates the attaches the user to the policy, and we are also getting two outputs. Let's apply this. Yes. Okay, perfect. As you can see, it creates a new output for the access key, and secret key is sensitive. Actually, this should be KY. Yep. Okay, and let's see. So if you go to let's go to bucket here, access, and you can see this user has access, and it has a policy called a Fireland test default policy which allows access to these buckets. Okay, perfect. If I go to the user service account, I can see that the service account is created, which is set to never expire. Okay, awesome. So I think everything is working as expected. So let me change the name to Fireland Valheim backup. Okay. So this creates a virtual machine. This creates a S3 bucket, associated user, and outputs credentials. So then I can set up the game server inside this VM and also use this S3 bucket using the credentials. That's exactly as we wanted. So for creating virtual machines like this, we just had to copy paste this part. Okay, I'm going to apply this, which is going to create a new bucket and rename everything. Perfect. So now this is the bucket ID, and the users are also changed Fireland Valheim backup default user. Perfect. So now I can add everything to Git. Before that, I need to do a Terraform format. Also need to format the modules. Okay. So Terraform module 4 is 3 buckets. Okay, let's go back to our to-do list. So we have set up the storage buckets. It's not here in the to-do, but we also created a separate modules for creating virtual machines. And yep, that's it. So in the next video, we will set up the uptime comma for monitoring the cron job, which does the periodic backup. And then we'll also set up the game server VM using NixOS. So we will see how we can configure a virtual machine. We will see how we can configure the entire operating system, install the necessary services, and start the server using Nix. Okay, thank you.